All right, so we're Team GrabW. So I'm Jason. This is Dustin.
Dustin.
Shaban.
I'm Tushar. I'm Tommy.
So on our second day of class, our professor was about 15 minutes late to class, and we were wondering why. And so Dr. Skinner told us that he had received a text message from Dr. Taka. It turns out that he couldn't find parking, and that's why he was late to class. So that inspired one of our project, which is a student-driven project, to try and find better ways to find parking on campus.
Alright, so basically the objectives or like what we're trying to achieve is that we're going to have a system of 4 JevWalk cameras on a light post connected to a Raspberry Pi 3B Plus, which allows Wi-Fi capabilities. And with that, we're going to try to create a parking detection mobile website where it will just display basically available parking spots in an area. And as like a reach goal that we're trying to achieve is that we're trying to make that as like an application as well. And so with that said, I'm going to pass it on to Shabam for our specifications.
So basically, we're just like, instead of a broad focus, we're just specific. We're trying to be specific on just UTD campus itself, because in the parking structures that we have on campus, they have individual, like you can see how many parking spots are available for what kind, like a gold, green, whatever. But for the outdoor, the old pre-existing parking lots, there's no way of knowing. So we're just trying to improve that way, because most people end up parking there, because I think that's where a majority of the parking spots are anyways. But so basically we're planning on mounting 4 cameras facing the parking lot on a lamppost, so that we have proper lighting during the nighttime, and when it's daytime you have proper lighting anyways. So we had to design a weatherproofing case so that the cameras can withstand Texas weather, whether it's really hot, really cold. So we have some specifications on that, and it's a little 3D model of what our prototype currently. And yeah, so basically the whole system just takes the cameras, Raspberry Pi takes the data, and then sends it to our server, and then from there you can access the data. So if, when you're leaving home, you can just check the website, be like, oh, there's parking here. When you get there, you can also pull it up again, because you're like, hey, I thought there was parking. You can just keep looking it up for every parking lot you want to, and we're doing a not specific parking spots, but just the frequency at which, or the how many cars. Is there a lot of cars in this parking lot, or the less cars? And at different times, how many cars where? So you can try to get the best chance of finding parking. And if there's any questions.
So have you guys tested this?
Not yet.
Okay.
So what we've tested so far, so the JevWalk camera does a lot of the processing on itself because there's a CPU on there. And so it has OpenCV and stuff like that. So all of the tracking and motion stuff, or just like, I guess, saliency maps for those, high frequency areas are all on that camera. And so we've just been testing, using the camera itself.
So some of the, this is about the third one of these we've seen. So some of the questions on this are, and you guys you touched on it, but it's not on your chart of, hey, this is outdoors, so it's where these other systems aren't already in place. Good selling point.
Yeah.
But I guess I lost my train of thought there. But anyway, that's a really good selling point for you guys. Oh, the question I had was, can you check this online ahead of time to say, hey, is this lot have a bunch of spots open?
Yeah.
That's what our goal is just basically create an application or a mobile website where you can just go, when you wake up for
yeah, you're heading off to class.
Yeah.
These lots
you'll see,
look like they got a
lot
bunch
H
of spots.
has this many parking spots available. What we're trying to do is basically maybe group them there's this many green parking, this many purple, this many orange.
Yeah.
That's kind of a density map of where you can park. Yes.
Okay, so two questions. One is, we have seen a number of these, and the assumption is always, well, we'll go do a GUI. That is a fixed amount of time. I'm a little distressed that I never see any kind of prototype of the GUI, because that can end up being a project unto itself. The second thing is you've got a Raspberry Pi in there, which is actually at least as capable as what I can barely read is the specs for that camera, with a dual-core GPU operating at 1 point something gigahertz. So why do we have a second processor in there that when you've already got substantial compute resources available on the camera?
So the point of the Pi is, so basically all the processing is done on the camera for a specific direction, and that's why we have 4. The Pi is meant to collect that data and send it back up to the cloud, where we can send that to that GUI that we're talking about, or that app that can be accessed by other people. We tried to make the cameras not do that much work so that they wouldn't heat up too much, or because these things are going to be outside. So we were kind of worrying about, I guess, how hot these things run, because there's like a little fan on top of that camera that does get kind of warm when you use it to process things. So we're trying not to let the camera do all the work, because we don't want it to burn out.
Yeah, so the Raspberry Pi is kind of just for sending the data from the cameras to the AWS server that we have, and then the GUI will just pull the data from the AWS server and display it.
So are you doing parking spot recognition within the Raspberry Pi, within the camera?
The
or
camera
on the
itself.
On the camera?
Yes.
Yeah.
Okay. But you're only taking pictures every 10 seconds?
Or
Yes.
fun.
You can do.
It's a video, so
Well,
we can
but
decide.
you said I'm recognizing availability of spots every 10 seconds.
Yeah, because we don't really need to care about like every
Exactly,
like,
yeah,
part of a
every
second.
quarter second.
Yeah.
So my point is that this is a lot of hardware for what you're trying to do. You're trying to evaluate 4 pictures in this diagram, 4 pictures every 10 seconds, which I think a Raspberry Pi could arguably do a good job of, and you would end up with spending a lot less and not worry about how much power you're throwing at the individual cameras. The other thing is, from a user perspective, I see a box that's likely aimed in one particular direction, and depending on where you are able to put it in a parking lot, where there's a light post, you might have multiple cameras needed just in that one spot to do the addressing. So those are the 2 things I think that we really need to work on here is, am I throwing way too much hardware? Yeah, it might be a good solution for an EDM, to say, look what we can do. But when you try to go and build a real product, it's going to be hugely expensive compared to what somebody else down the street will go and design and cut your price in half.
Thank you.
Thank you.